What exactly is a neural network? In this video, we will cover a wide approach using an example taken from an article titled Classification of Vintages of Wine by an Artificial Nose with Neural Networks. Then we will be getting into a technical example taken from a MatLab Neural Network pattern recognition application. Artificial neural networks are loosely based on how the neurons in your brain are used to solve really hard problems. In the example of classifying wine vintages, the odors were presented to a sensing system, which generates a pattern, which is then presented to a pattern recognition system, or neural network, and classifies the odor as one of the vintages. 3 different vintages of the same wine were to be classified. So to describe how neural networks are programmed, we must understand its basic structure. Using polymer sensors to measure resistance values for each of the wine vintages, over 5,400 patterns of data were gathered. The data was then partitioned. Essentially, you have input data which must be represented as integers or floating numbers. This is called the normalization process, or encoding. This is because for the neural network to properly understand the data, it must be represented in a way where the computer will understand its units. Hidden nodes are for computation. One hidden layer was used. These lines represent synapses, which are taking values from an input and multiplying it by a certain weight, giving an output. Neurons, or nodes, add outputs from all synapses and apply an activation function, which helps model complex nonlinear patterns. In the research, sigmoidal activation functions were applied. Our examples are classification problems, so our outputs will be given in what we will likely understand to be a probability, which will then give us the most likely answer. This work presented results for pattern recognition in an artificial nose and compared them to a MLP network. The system was able to show satisfactory performance in pattern classification and was able to distinguish odors. What determines the number of hidden nodes? Well, different number of nodes should be experimented with. The more hidden nodes you have, the more flexible your neural network becomes. But if you have too many, you begin to overfit the neural network. Now that we have a very basic idea of what an artificial neural network can do, let's take a look at an example in MATLAB. This is a classification type of problem which involves identifying 13 attributes of 178 types of wine through the use of training data.